Solve, graph the solution set for the inequality 5 over t minus 4 is less than or equal to 1. Let's start by getting everything on one side with 0 on the other. So subtract 1 from both sides, and let's write this as 5 over t minus 4 minus 1 is less than or equal to 0. Next, let's get a common denominator here and combine these terms. So this is 5 over t minus 4 minus 1 is equivalent to t minus 4 over t minus 4. That's less than or equal to 0. Now let's combine our numerator terms and watch your sign very carefully. The denominator is t minus 4. In the numerator, we're going to have a 5 minus t and plus 4. Well, 5 plus that 4 is 9. And we'll also have a minus t. Watch your signs very closely there. Now, we're going to set up a interval of values at this point. A rational function is going to change from positive to negative or vice versa at values, in this case for t, that cause the numerator or the denominator to equal 0. The numerator will equal 0 if t is 9. The denominator will equal 0 if t is 4. So let's locate those values on our interval here. T equal 4 and t equal 9. Now before I move on any further, so I don't forget later, in this rational function, we won't be able to use t equal 4. That's going to make this denominator 0 and make that undefined. So I'm just going to make a note to self. I'm not going to be able to use that number 4 in my solution set. In the numerator, if t is 9, that gives a numerator value of 0. Divided by any non-zero number is 0. So we're okay with that one. Now, let's test a point from each of these intervals to see if that interval is going to satisfy our initial inequality. 5 over t minus 4 is less than or equal to 1. So we're going to test a point from A, from B, and from C. From A, I'm going to choose t equal 0. That's a number that's clearly smaller than 4. Now, is 5 over 0 minus 4, or is a negative 5/4 less than or equal to 1? Sure, that's true. From interval B, let's choose a value from between 4 and 9, like say t equals 7. And let's check it in this inequality. Is 5 over 7 minus 4, that's 5 over 3, less than or equal to 1? No, that is false. Those values do not satisfy our inequality. Lastly, from interval C over there, let's choose a number that's larger than 9. How about t equal 10? Is 5 over 10 minus 4, that's a 5/6, less than or equal to 1? Yes, that is true. And so, our values that are going to satisfy our inequality come from this interval A and that interval C. Let's describe those intervals using interval notation. That's negative infinity up to 4. Now I can't include 4 because 4 causes that denominator to be 0, so don't include that. Union 9 to infinity. Now I can use the 9. That causes the numerator to be 0 and gives us our equal to part from our inequality up above. So that's a 9 to infinity. Lastly, if we want to show this as well in graphical form on a number line, I'm going to start by locating 0. I'm going to locate 4. I'm going to locate 9 and indicate these numbers as from negative infinity up to 4, not inclusive, from 9 out to positive infinity, and we do include the 9.